All righty, welcome everyone to the Cyberbot Educator Workshop, day one, more officially named the Cyberbot Robot with Python and the Microbit 3-session Educator Workshop. This is the late March 2023 installment, so if you're fairly close to that and not in a future year, this would be your latest and greatest version of the Educator Workshop to follow along with. For any of those of you who want to follow along with this presentation, and I highly recommend having this open or at least having the link. I'll go ahead and paste this through to the chat. You can go ahead and open it. And the main reason to have it or bookmark it is going to be, well, one, you can go to a particular slide if maybe I moved on and you want to look at something. But two, it has a lot of links to important and useful resources that I'm hoping you'll be able to use when you use the Cyberbot in your classroom. And so, so yeah, we definitely want you to have this at your disposal for future reference. And here it comes in the chat. There we go. Okay, so with you today are me, Andy Lindsay. Ari Alvarez may come through briefly. He's our company VP and education manager, and Stephanie Lindsay, that's my wife, will be on the looking at the chat, making sure that all your questions are answered if they come through that direction. Also, you can feel free to just unmute yourself and say, hey, Andy, can you give me some more time if we're on a particular step and you're not up with us? Or, you know, hey, Andy, I've got a question. One thing I recommend for this workshop, for those of you who have more than one screen, it's going to be pretty easy. You can put the Zoom presentation on one screen and then maybe have stuff to work on like your editor for the Microbit on the other screen. Now, if you only have one screen, what I'd recommend is getting out of full screen mode. So the Zoom presentation is probably taking up your whole screen right now. And so what you can do is in the upper right, there's a little tiny view button. You may need to wave your mouse around above the presentation, and then you'll see a view button, and you can click that and select exit full screen mode. Then you can resize your window. And so I recommend maybe resizing it over on the left, and then we'll want to open a Chrome browser and go to a couple of python.microbit.org/v/2 editors. I'll go ahead and, so for example, you might be, let's say that this document camera that I have up on the left is the Zoom meeting. And again, you'll want to go to the upper right, click View, and then click Exit Full Screen Mode and resize the window so it takes up some portion of your screen, like maybe the left half. And so then it might look like this. And then in, say, the right half, you could go ahead and go to python.microbit.org. I'll paste this in a second. It's going to be /v/2. We're going to use the V2 editor as opposed to the V3 editor, which is their latest and greatest. And the reason for that is because we have many hundreds of photos and instructions that reference the V2 editor. And so an update can't really happen until summer at the soonest. Okay, let's paste this in. And so so the instructions are all set for the V2 editor, and that's why we're using it as opposed to the V3 editor. Both are perfectly fine for all applications with the Cyberbot robot, as well as with the Microbit itself. Okay, let's see. I see some questions coming through. Do you want these now or to wait for a more opportune time? I would say go ahead. One of the reasons I brought this up before even the intros is to give you some time to get going on this. So yeah, go ahead and tile your screen, and then you can use the view the full screen. You can switch back and forth between full screen and part of the screen with your presentation. And when it asks you, when the Python editor asks you if you want to try the new editor, let's skip that, go ahead and close the window or hit not now. And so that way you'll have your Zoom presentation in part of the window, and then your python.microbit.org editor in the other part of the window. And then along with this, I'd like you to plug in your microbit and make sure that it's connected. And then that way we can all be doing that and kind of multitasking as I'm doing the rest of the intros. Everybody okay with that? I'll take silence as assent. Otherwise, a hey, wait will suffice to answer any questions or slow down. All right, so for the agenda for this week is, well, if we talk about the learning outcomes on the right first, we want to enjoy ourselves and participate. I'm hoping that by the end of the workshop, you'll have a good hold on the resources and where the various ones for students and teachers live. And I want to make sure during this workshop, very importantly, to address any challenges that you might run into in the classroom. One of the most important ones is something called adding the Cyberbot. We used to refer to it as a library. It's actually a module. And so you'll see this today. And essentially helping students get the system up and running. So when they enter code, finding and fixing syntax errors is going to be another one that we want to make sure you see an example of how to do that. We'll talk about building the circuits and building circuits on the Cyberbot robot, because if you look at this, these are circuits. This is one of the circuits that can be built on the Cyberbot robot following the instructions in our lessons. And these are real electrical and electronic parts, as opposed to some kind of pre-made block that you can connect together to have it, serve some purpose. And one of the reasons we did this is to give students direct exposure to real prototyping parts that they might, later in a profession encounter again. Okay, coming back to the goals for today, and then I think just to summarize the rest of the goals, it's mainly to help you kind of know any of the things that might otherwise take a really careful read. If you might have missed something, I'm hoping that the workshop will have emphasized any potential gotchas that would otherwise be, a line by line read. And if you missed a line, that might cause some frustration or confusion. And so that's what we'll be focusing on. And also the educator resources, which we'll talk about on Friday. So today we'll be focusing on getting ready to put our Cyberbot robot together. Before that, we'll do just some intros and overviews of the Cyberbot, of Parallax, and of some of the history leading up to it. We'll talk about the homework that you already did briefly and have some questions and answers. We'll also then add that Cyberbot module to our project. This is something that even if you've have some experience with the microbit, you might not have done that yet. So it'll be new for everybody, regardless of how much experience you might already have with the microbit. Then we're going to not calibrate the servo motors, because your servo motors are going to be pre-calibrated. But we are going to connect them to the board and just verify that we can make them run at certain speeds and in both directions before putting the robot together. And your assignment between today and Wednesday will be to put together the robot. And that's, of course, after we've tested the servos, just make sure they're all running. Okay, so I see some chats here. See, I noticed that the pins on the Cyberbot board don't line up with the microbit pinout. See, assume this is because propeller much. Okay. Yeah, this is a pretty deep question. I'm gonna let this one be on the back burner. There's a slide that has a good overall view of both the pins and the second microcontroller that's underneath the Cyberbot that does some of the work for the system. So I'm going to put that question off until later. Again, discussion is encouraged and appreciated, so you can feel free to unmute and ask questions, and also tell me to slow down if I've left you behind by going too fast. So in terms of intros and overviews, the Cyberbot robot is begotten of a partnership between Cyber.org and Parallax. Cyber.org is down in Bossier, Louisiana, Bossier City, and they have a staff of about 25, and they've been around for well over 10 years now. And one of their primary directives is to create a cyber-ready workforce. They make a lot of free curriculum available for educators in the US, and I'll be talking about that also on Friday when we go over the resources for educators. We're going to mainly be in the student resources for the first 2 days. And then we are Parallax. We're in Rocklin, California, just outside of Sacramento on your way to Lake Tahoe. So kind of pretty much in the middle of the state. And we have about 20 employees and have been around since 1988 and in education since 1997. This is Chip Gracie on the left and Ken Gracie on the right. Chip is our chief inventor and Ken is our CEO. These two brothers have made really an amazing company that does great stuff, especially for education with electronics and microcontrollers. About myself, my name's Andy. My background is in electronics engineering, and I've done a lot of things over the years in terms of writing books, designing electronic stuff, and most recently, the Cyberbot and the Learn circuits with the microbit kits have been two of my more recent foci. As far as Parallax is concerned, if you're curious about what Parallax does from a 50,000 foot view, our main focus is on introducing the technology that goes into both products and inventions. So along the top, we've got some products, and if it has a display and some push buttons, chances are that it has a microcontroller that's been programmed inside it to be the brain of that device. And then that microcontroller will, in the example of the microwave oven, be checking for a circuit change on the keypad. And so when you press the key, the microcontroller detects a circuit change. It sends a rapid series of high and low signals to a speaker to basically make it vibrate. So when you press the button, that's how it makes a tone. It updates the display and all that other stuff. That's usually done by firmware. That's a program that's written for a microcontroller to essentially make it and a collection of circuits and some kind of package into a product. Microcontrollers are also commonly used in inventions and student projects, which is some examples are shown down below. We have one of the earliest big splashes that Parallax made. Chip Gracie invented the BASIC Stamp 2. And this was the microcontroller that in the late 90s took, it basically changed electronics education and hobby electronics and even professional prototyping from the kind of thing where it took some specialized education in order to connect a circuit to a microcontroller. And it took it from that to pretty much anybody could do it with this new thing at the time that was programmable in BASIC, which at the time was the beginner's language of choice. And it made everything very easy to do. You did not have to know assembly or machine language. You did not have to buy special software. It was just a free download. and it made everything really easy to get started, very convenient for education. So it was taken up pretty rapidly into that world. And so that's to that end, we made the Bobot robot, which is this little green robot here. And since then, a lot of microcontrollers have joined it's let's make it easy to use as opposed to a professional kind of device that is used only by engineers to be designed into products. And so here are some examples up top. These are some of the robots that we use to introduce microcontrollers. And the most recent microcontroller that we've added to the series is the microbit, which was invented and distributed by the British Broadcasting Corporation, the BBC. And what they did was they made over 1 million of these and distributed them to middle school students. And that's how the microbit got started, was on a pretty grand scale. And the microbit, in addition to having a microcontroller brain, which is on the back side, this little chip right here, it also has a whole bunch of built-in stuff that you can write scripts for to get things done and have some gratification immediately. And it's also kind of a microcosm of a cell phone. It has a little tiny display. It's got some buttons that you can press. And of course, the program that you write, the script that you write, is going to determine how the buttons behave, how the display works. It also has a microphone, a little touch sensor. It has some pads along its bottom that you can connect to you can use to connect to circuits. And I see a question: are we supposed to have 2 microbits in the kit? No, just 1 microbit. There is radio communication options available. If you have a second microbit, there are some fun things there. Back to what's on the microbit module. It also has a built-in speaker on the back, a reset button, and a small chip that is a compass and an accelerometer, which opens up a lot of really fun options. I'll show you one of those in a minute when we get to some of the common uses of the microbit before students might get started with the Cyberbot robot. So here's the BBC microbit in a nice picture, and here also it is shown connected to the Cyberbot robot. So coming to the workshop in day 2 on Wednesday, you will have this robot put together, and we'll be ready to start making it navigate. Now, just a couple last things before we dive into getting started with some of the hands-on stuff. Stephanie, are there any questions?
Nope, you just answered the last one about whether it's 1 or 2 microbit modules that come in a kit. And it's just 1, with the thought that in a classroom setting, the students would have their robots microbits talk to each other, though individual Go kits are also available.
Yeah, and the Go kits, what's their price right now?
I think they're on sale for $18.95.
That's a pretty good deal. So yeah. Yeah, so if you want to try some of the radio control robot projects that require a second microbit, now's a good time to order one. Yeah, a few things I wanted to say ahead of time. I'll probably show you these same slides on Friday because they're really important. Is one, the student lessons. So they're at learn.parallax.com, and I have the address right here. So if you go back to the slide at some point, you can simply click the address or even the image and follow the link. What I'm going to do, though, is go to learn.parallax.com and show you also how to navigate there. So here is learn.parallax.com. And when we get there, we'll see grades 9+. Now, that's not written in stone. But in that category, we have the Cyberbot robot. And so what you can do is simply follow that link. And when you do, this is essentially the student textbook. And each of these tiles, you can think about like a chapter. And not all of the tiles in every section are required, even though we do call these prerequisites. Not all of them are prerequisites for the Cyberbot itself. Typically for the Cyberbot, yeah, there's the setup, which is connecting the the microbit to your computer, and then how to save and reopen a script with the Python editor that you did during the homework, and then how to write programs. And last but not least, how to add modules to your microbit. There's a Cyberbot module that you'll be adding to your microbit, and I'll get back to this in just a little while. Just letting you know that these first four are kind of the key ones as far as prerequisites for the Cyberbot. If you're in cybersecurity, doing the cybersecurity tutorials, those go a little bit more in depth into some computer science concepts, and that's where computer microbit talk, dictionary primer, exception handling, and strings. Those ones get used a lot more in the cybersecurity portion of the tutorials. If you're just doing the robotics, just these first four are great. And then in the main lessons, we've got a chapter on how to build your robot. Then there's navigation, making sounds, building circuits. Then we go to touch navigation, visible light navigation, infrared navigation, and then on into some of the cybersecurity topics where we start to add radio communication and data. And then that allows you to use a Cyberbot to say, or an extra microbit to control a Cyberbot from the computer keyboard, or since it has a built-in accelerometer, you can use tilt control. And then there's some more cybersecurity lessons that can either be microbit only, or they also have a Cyberbot component to them. And last but not least, there are some extras that are included in the classroom packages, which are 12 packs that have 12 Cyberbots, but also have additional parts. We've got parts for a line follower, parts for a rotating ultrasonic distance sensor, and then a TV remote. So these all come with the 12-pack kit along with some batteries, and this is documentation for them. And I'll be opening a lot of these chapters during this workshop. So don't worry, I'm just kind of trying to give a 50,000-foot view of what's available inside the student lessons. Oh, for teacher resources, we also have a link for that. And I'll just show you how to get there. If we start back at learn.parallax.com, you can just click educators. To get to the assessment materials, you'll end up having to log in, and we'll have you get ready to log in between Wednesday and Friday. And then with that, let's see, Cyberbot resources are the third link. And there are some public resources like the standards alignment matrix and scope and sequence document. But to get to assessment materials, you'll need to log in. And again, we'll do that between Wednesday and Friday. And then I'll be talking about the educator resources on Friday. As far as purchasing goes, here's a link. Go ahead and paste this one into the, so this is at parallax.com. And when you get there, you can click shop, and then you'll see our catalog along the left, and then Cyberbot is one of the categories. And so this is all things Cyberbot. And so here, for example, is the 12-pack. I forgot to mention earlier, I think that it has a rechargeable set of rechargeable batteries, enough to keep students going on a daily basis, enough rechargers and batteries to keep 12 robots going on a daily basis. There's also the individual robot, which comes with everything except for the projects. So earlier at learn.parallax.com, I talked about some extras that were at the bottom. So this was the projects section. And so if you buy an individual Cyberbot, these parts are not included, but they are included in the 12-pack. And so this individual Cyberbot has everything in the prereqs and main lessons, everything you'll need to do all of this. So it is an entire textbook's worth already. And for those of you who are looking for some additional projects for your students to try, that's where these optional add-ons, if you have individual Cyberbots or included with the class packs, come in and are documented. And we also have an all things microbit category. And again, you could also look for microbit, click shop, and then look for microbit. And then there's even subcategories within microbit, depending on whether the interest is kits or the robot, etc. And last but not least, on the intros, we do have some upcoming workshops that are still have some openings. And so I put a link here, and did I forget to paste in the link to the Cyberbot stuff? I think I did. So here it is in the chat. And then here's another link in the chat, and this is for the upcoming events. You've probably been to this page since you signed up for this workshop, but I want to bring to your attention that there are some more workshops coming up. And specifically, so this is the workshop we're all in, which will be moved to the past events category. And in the past events category, let's say that you ended up or have some ShieldBot robots made by Parallax in your parts closet, and there's not a upcoming event currently scheduled. Well, you can go to view event, and there's video recordings of all 3 days of that workshop, 3 2-hour video recordings, and they're all up top. And then down below, here's a link to the slideshow as well. And so you can follow along with any of our older, or rather any of our previous workshops by, again, going to that past events tab. Then you can see all the workshops that we've done previously recorded and put on YouTube. All right, so that's our intros. So before I move on, any more questions? Ooh, I like the thumbs up. Thank you. Let's see. And then, and the thumbs up is actually for a technology grant that Stephanie pasted in. Yes.
Yes, it's currently, the current cycle is closed, and I think it will start up again in the fall, most likely. So I put the link there so people can bookmark it for the future. Okay, fantastic. Thank you. And then, all right, so moving on, quick review of the homework. One of the things I sent out was basically some instructions on connecting your microbit and communicating back and forth with it through the terminal in the python.microbit.org editor. So that document is linked here. And by the way, this is primarily a teacher resource. I found out that a couple of teachers have used it in their classroom, which is fine. It's just, I didn't quite intend, I intended this to be sort of a quick start to get everybody going, because if we go to learn.parallax.com, the student textbook supports all of this. It's just a little more methodical about it. So learn.parallax.com. So essentially, students would go to the Cyberbot book, and then they'd open the software setup for microbit chapter. And they'd go step by step through here. They'd connect their they'd decide which software to use. And we always recommend the online Python editor as opposed to the Mu editor. We've had some tech support issues with Mu. It's not as smooth of an installation, or it doesn't always work, even depending on your environment. Like, I've had a lot of trouble with my Mac on this. Installing software. So basically, that's opening the Python editor. And
And then it takes you step by step. So each part of the lesson that is an action item has a little red check mark next to it. And then this is the connection test. So some of this should look familiar. This diagram is probably familiar, but the student tutorial takes you step by step through this. So you can use this. This I set up for the teachers, and let's go ahead and zoom that a little bit. So all you folks, and so I included a little video companion to it, and all we did was essentially make sure that your microbit would talk to your computer. So I'll just demo that really quick. Normally, I recommend typing in the script examples because that helps learning both for you and your students in many ways. For example, making syntax errors and figuring out where they are, fixing them and having the script actually run. And then there's just the fact that typing in with the tutorial side by side with your editor ends up being super helpful. So normally when trying to learn the language, your setup might look more similar to this, where you've got your script example side by side with your Python editor, and you'd be typing in the example here. To save time and get us through kind of a hands-on intro to all the material, we'll be doing a lot of pasting in of scripts, even though at your leisure, hopefully in the future, you'll be able to do some hand entry of some of the scripts to get a better feel for what they're about. At any rate, so testing out your microbit, you'll click connect. And I clicked connect and did not see any microbit modules. So that is probably because if you look at my thumbnail, I forgot to connect them before the workshop started. So pardon me while I do that real quick. When you connect your microbit, you might see a file browser automatically appear. And for the most part, you can usually close that. So if you have a new microbit, it'll go ahead and make a lot of background noise and display some stuff. And then on your first program load, normally you'll click connect to connect the online editor to the microbit, and a dialog comes up where you have to choose the microbit you want to connect to. There's usually only one in the list, maybe two if you have a second microbit connected to your computer. So select it and then click connect. And then to load the script, you'll hit flash. And again, it takes a little longer on the first try. And wish I'd have remembered to do that before we started. Sorry for the delay here. Be about 20 seconds. In the meantime, while that's loading, yeah, I don't really want to skip to how to save and reopen your script quite yet. We'll just wait for this to load. And again, this is a review of the homework that was done getting ready for this workshop. So this was a list, and keep in mind that you have a link to the test your microbit homework, to the how to save and reopen a script homework, and then to all the chapters, along with to make life, or to make everything go quickly, the specific section that I wanted you to take a look at if you had not previously programmed in Python to get more comfortable with the language. And that's where hand entry would be a big help. Okay, so now the script has completed. And so normally when you hit flash, it's just a really quick boom there, it's all loaded in. And after it's loaded in, what these instructions said was to go and click Open Serial. And a new microbit will display a whole bunch of, I think these might be accelerometer tilts, tilt measurements. So eventually it gets through those from the previous script that was running and shows you type a message, and then you can type a message or hello or whatever you typed. And the important thing was to have it repeat back to you after you typed something and hit return. It is supposed to correctly tell you what you typed. And what that does is just verifies that for this workshop, you've got back and forth communication on this terminal here, as well as being able to load a script into the microbit. So then we have the save and reopen a script part. So let's do that real quick. So what we want to do is everybody go ahead and open your editor, and I'll paste this into you in the chat. So you can copy and paste this from the chat into your microbit editor. And this is just for the sake of example of saving and reopening a script. If you're comfortable with this, that's great. And you don't need to put it in, but if you do put it in, we can give this script a name by copying. I didn't do that right. Okay, we can copy the script name, or just type it into the script name field. I chose to copy it from the comment at the beginning of the script, but you can also just type it in. Once you've got it named, then click Load Save and select Download Project Hex. And what will happen is that Project Hex gets downloaded, and it's going to appear in your Downloads folder. And so for me on this Mac, I use both Windows and a Mac, but this Mac has been really good for the Zoom presentations. So when you look in Downloads on your Mac, text, especially if you have it sorted by date so that the most recent thing is first, text loopback test will appear on the top. And the important thing for closing or saving and then reopening files is, let's say that this goes away. Now that we've saved it, we have a copy of it. And so one way to make this go away is to simply hit the little refresh button next to the address in your Chrome browser. And when it reloads, all the work that you had was gone. You can either not now or X out of that dialog. And now we're back to the default script that displays hello world on the display, the 5x5 LED matrix on the microbit. And so sure, we could run that, or we can go ahead and open up a previous program like this text loopback. And so one quick trick to open a script in most cases is you can just open your file browser and drag the .hex file that you want from your file browser's downloads folder, and you can drag and drop it into your python.microbit.org editor, and there it is open. I think that the way in the instructions, just to make sure it covers all operating systems, is to click Load Save, and then select or browse for file. And it'll take you to the downloads. Normally, I was in a different folder. And then up top here, I found the text loopback test.hex. And so I'll go ahead and click open. And then here we are again. So, so those are some ways to open a previously saved script. And again, to save, set the name, then click Load Save, then use Download Project Hex. In most cases, you won't need download Python script, and there are some drawbacks to it. Some browsers warn you that there might be a virus in it because Python can contain executables that could be harmful or malicious for a computer. Whereas the project hex is a pretty inert thing that you just open. You can really only open it with this online microbit editor. And so that's part 2 of the homework. And remember, set the script name, then click load save, and then download project hex to save your work. And then this is a list of real quick, short examples that we went through to, especially for anybody who's new to Python, to get familiar with it. So if we went to solve math problems, for example, it just said focus on the simple math example. And Stephanie, you are.
Yes, there was a question that came up. It was, can you also just load the .py file?
Yes, absolutely. You can save and load the .py file. However, that will have consequences with the Cyberbot. And that has to do with containing a module. So I'm going to come back around to that. So for now, yeah, if you just have a plain old program for the or a script for the microbit, you can do load save and you can hit download Python script. For some of you, there will be a big warning down here saying, hey, this could contain a malicious, script that could harm your computer. So that's one reason not to save the Python version of the file. And yeah, if I reload the if I nuke the previous script, and so we're back to the default script. By the way, also, if you can see what you downloaded on the downloads bar at the bottom of Chrome, you can actually drag and drop it from there to reopen it. And in this case, this is a .py file, a Python file. Yes, it works, but generally, I recommend to just about everybody that they save it as a hex file. There are some cases where somebody will want to view it in a text editor. That's a reason to download the Python file. Hex it will be, okay. I will move on then. So again, this is not something I'd want to do while trying to learn the language, but just as an example, we'll take a look at so here we are in Solve Math Problems. It's the third activity in the Writing Microbit Programs chapter. And so here we have, we were going to focus on simplemath.py. So all we were going to do is enter, save, and run this file and see what happened. And these examples that are written for the students are going to use display.scroll. So print is what caused things to appear over here in the serial terminal. So like if we go to loopback text, this has a print statement. And so when we connected and ran it, so connect, flash, and open serial were the steps for that. We saw messages here in the terminal. But when using these examples that are in the student workbook, these use display.scroll. So they will not appear over here with open serial. They will instead appear in the microbit itself. So if I run a script that is supposed to display 89 plus 42, it's going to be, sorry, I had it upside down. I'll reflash that. So if you look at my thumbnail by the presentation, it's going to show that the solution is, what was that? Let's see, 89. I'm just going to print it so I can see it too. So it should have displayed 131. A plus B equals 131. All right, so that's an example of something that the students are going to work through. Multiple activities here. They go through the scripting basics, and then they also experiment with push buttons, writing functions with which I don't really consider a basic, and then another computer science topic, which is local versus global variables. You didn't see how I got print. I just quickly added a print statement here. I said I added print C so I could see it in the terminal. Because when I'm presenting, sorry, my brain turns to mush when it comes to, mentally adding two-digit numbers. It's pathetic, but that's the way I am. So I just needed to have the microbit do it for me. Okay, so a little note about the first few activities in the first chapter is that they focus on what I consider to be the programming basics, which would be communication, recollection, calculation, decision, and repetition. So those to me are the basic building blocks of computer apps. And so just a quick little overview. I put all of those together, all of those little examples together into a script that is hopefully not too long for the chat. It went through. Okay, so go ahead and try this one on your microbit. And I'll go ahead and run it too. So I pasted it into the chat. And so here we have a program that has the communicate, remember, calculate, decide, and repeat routines all in one script. And so I'd like to just go through and make sure everybody's okay with how this works.
We have some questions here. I
Okay.
don't see how you got the print.
Oh yeah, I just answered that one.
Yeah. And let's make sure that was covered.
Yeah, so I added print of C.
Mhm. Okay. And just a request for some extra assistance from a newbie. I know that just for everyone to know, after the main presentation, we can stop the recording and have some one-on-one question and answer time.
Okay, and yeah, we'll also have a short break during which time
This
I
is
can
true.
try to help you out as well. Let's see here. Why is that not? Okay, I want to run it and then open Serial. Okay, so I added a bunch of press enters to continue. So the first one is an example of communication. So we're using print hello, and there hello appeared in the terminal. Then it's waiting for me to press enter to continue. So I'll go ahead and press enter. So the next example is going to be remembering. A is 2, B is 5. F is set to 1.414 as a floating point variable, and T will be equal to text. And we'll go ahead and print all of those. So the remember part is setting each of these variable names equal to each of those values. And then the recall part is when we print it, the microbit has to go into its memory and find each of the values that correspond to those letters by setting up these equalities and show them to you. So when I press enter, I want to see 2, 5, 1.414, and text. And then there they are. Is that viewing okay for everybody? How does it look to you, Stephanie? Is the text is large enough and everything?
I think so.
Okay, I can go a
Everyone's
little bit.
monitor's different. Yeah.
Yeah, go a little bit larger.
We have another yes in the chat. So
Oh, good.
and nobody's
you.
saying they can't see it.
Okay. So we just did remembering, and now it's waiting for me to press enter, and we'll do calculations. Now, A was what, 2? Yeah, A was 2 and B was 5. So C equals A plus B should say C equals 5. I meant C equals 7. 2 plus 5 really is 7. Okay, and then for press enter, this time it's going to decide. Now A is 2 and B is 7. So if 2 is greater than 7, well, it's not. So it's not going to print A is greater. But otherwise, if B is greater than A, 7 is greater than 2, it's going to print B is greater. And remember, this is harkening back to where we set those values earlier on.
Was this from Solve Math Problems?
Yes, what I did was excerpts from everything. So this is kind of a brief version of an excerpt from Communicate, although the Communicate lessons used the LED matrix display instead. This is an example, and instead of the matrix display, we're just using the print statement to make it go faster. And that was from Remembering. And then this is similar to what we saw in Calculate. And this is going to be similar to what we saw in the Decisions activity. And so when I press enter here, it's going to say B is greater. Now, as soon as it finds something that's true, when you have if, elif, else, and you can have multiple elifs in here, that's kind of shorthand for else if, it'll go ahead and when it finds one that's true, when it finds a condition that's true, it does that. It does the thing or things. So you could have one or more things below and indented from, I just use some Windows keys instead of the Mac keys. Bear with me a second. Okay. So if, for example, we have 2 statements indented, below and indented, it'll do both of those. Disconnect here. Load the script here. I'm just using 2 windows, one with the script and one showing the terminal flash. So you don't need to do this. So disconnect there, connect in this one. Okay, let's get caught back up to. Okay, now, since I had 2 things below and indented from if B is greater than A, it says B is greater, really it is, because there's those 2 statements below and indented from this condition. So it does those, but it doesn't do anything else. It skips out, doesn't check anymore. Now we have repetitions, which have a couple of different flavors. One is counting a certain number of times. And this also automatically adds 1 to the value of n each time through this loop. So it's going to print the value of n and then sleep for a little while, 350 thousandths of a second or 350 milliseconds. So when I press enter again, we want to see it count to 10. There we go. And another kind of repetition is an infinite one, and that's usually, or an endless loop. And that is usually what your applications like your alarm clock and microwave oven and other devices are programmed to be inside. And so when I press enter, it's actually going to resume starting at 10. And incidentally, that's one thing that some folks find a little bit confusing about the for loop in Python, is that when you say for n in range, you want it to start at 1, yes, but it stops at 1 less than the ending value. Notice that we said 10 here, but it only counted to 9 in the terminal. And so when I press enter, it continues at 10. It might have been because I didn't copy and paste everything. because I see some missing stuff. Sleep. Let's do 250 and n equals n plus 1. Sorry about that, folks. I made a mistake. So if we flash this, okay, so now I'll disconnect and then connect to serial here. Okay, so it's going to count to 10, and now it should count from 10 onward. And sorry about that. I'll paste this corrected code into the chat for you. Okay, so there's the corrected version. It was instead repeatedly displaying 10 over and over again because I probably didn't copy in the whole script. Okay, so just a couple more things before we take a break. And then we'll get on to starting with the robot. So very quickly, I wanted to show you about some resources as kind of a warm-up or an icebreaker if your students have not done like a previous microbit in a previous class term. You can do a lot of fun stuff. I think we'll try the step counter. And these are all examples from the Make It, Code It projects in microbit.org. So there's a direct link here. I'll open it and then paste in the link and then show you how to, actually, I'll show you how to get there first. What you can do is after you follow the link, it's going to drop you here and you'll see that there's some videos on how it works. And then there's the script. Now, by default, it's going to show you the MakeCode block version of the script. So this is the block coding way that you would count the number of times you shook the microbit. I'll paste in the link in a minute. Don't worry. I wanted everybody with their heads on the screen for this because it's important. It's easy to miss this part. So you'll see the MakeCode blocks. But what you can do is click the Python tab, and then it'll show you the Python version, which you can open in Python, but what it's going to do is it's going to open a new editor, and you've already got and it's also going to open it in the 3.0 editor, which is cool. But then you'll have to go ahead and connect that. So I recommend just taking this this script right here and just shading and copying and pasting it. Of course, again, hand entering is better. And then pasting it into your editor like that, the one that you've already got open. Okay, so with that said, I'll go ahead and paste in the address. We'll have you get the script, paste it into the editor and load it into your microbit, and then get ready to shake your microbit and see how many steps you can shake into it. Let's see, where did my microbit go? Here it is. Okay, so connect, flash. And now in my thumbnail, when I shake the microbit once, it'll show me a 1. Second time, should show me a 2. Third time, 3, and so on. Every time I shake it, it's going to give me an updated step count. And so that's an example of something that's cool that you can do with just the microbit on its own, with its built-in accelerometer and script execution features. And I guess while I'm at it, I'll paste in the code. So you can either follow the link and copy and paste from there, or just copy and paste it out of the chat. All right, and let's see here. Okay, so can I get some thumbs up on if you got that to work? Good job. More thumbs up, oh, excellent. Way to go, everybody. Looking good. Got a few from, see, I must be missing a step. I have web USB errors. So with that web USB error, could you shade and copy it into the, so one thing is make sure you only have one browser open. So I'll show you an example of how you can create a web USB error by mistake. So here I have this, let's see here. Zoom out a little bit so you can see the labeling. There we go. And then I'll just increase. All right, so this is what's connected right now. See, it's giving me the disconnect option. Now, if I tried to connect here and load this script in a separate editor, what might happen, it depends on your computer. I don't know if mine's going to cooperate or it's going to get stuck. So it cooperated. Let me try opening the serial over here. And then again, flashing over here. Let's see if, there's a web USB error. So this one says, please reconnect your microbit and try again. The reason for this is because my serial terminal is open in a separate editor, but I tried to load the script while it's connected to that serial terminal, and most computers don't let you do that. And so if you have more than one Python editor open, that may be the cause of your web USB error. Okay, let me get back to the chat. Was that, did closing bad response 8 to 17? I don't know. If you try a second time, does it work? And maybe you can hang with us a little bit during the break. Let's see, I also added print steps, and now I can see it in the serial monitor too. Oh, nice work. All right. And I got, yeah, so most of you it's working for. We got a break coming up. Like I said, just hang with me briefly, and I might be able to get you unstuck during the break if you don't need to take a break yourself. So these are a few examples from this Make It Code It projects page on microbit.org. And there's a lot more resources like this that you can see. I put in a slide with a couple of YouTube videos that show microbit only activities that you can do, and also microbit.org curricula that's available to teachers, and some of the additional resources that they have. And most of those are in this first YouTube video on the left. And then just a quick thing about how to get help. Like, let's say that we're in here and maybe in range doesn't make sense. Well, you can hit help and select documentation, and then search for in range. I may not have chosen well there, hopefully. So I see range here, so let's try this. Okay, so this is a larger example going back. Yeah, I chose a bad example. Let me look for another one that's going to be easier to find. So let's say, oh, sleep. So sleep would be a good one because we have sleep in some of our scripts, or display.show would also be one to check out. And so we could search for sleep, or I'll do display.show. And when we search for that one, microbit MicroPython API display. So that's one way to look up something if you don't immediately understand it in a script. And so we'll have to scroll down and find display. Oh man, I'm just striking out all over the place today. Here is display. So that was on the left. And then it talks about all the different things you can do with the display method in MicroPython, and gives you an explanation of each one. And then it also will give you some example code to experiment with. And with that, let's go ahead and take a quick break. Let's make it a 7-minute break. It's 8 past the hour right now, so we'll see you again at 1/4 past the hour. And for anyone who's still getting, Kathy, are you there? Okay, welcome back, everyone. Let's see. I think that we left off. I was just basically talking about the how to look up some of the things you might see in a script. Now, I'm going to fast forward a little bit. There's a whole lot of examples that might be nice for your classroom, but are not going to fit into a 2-hour session. And so we're going to skip to build and test your Cyberbot. And so what we're going to do now is go to the student activities, and it introduces the Cyberbot board, which you've got in your box. It's going to ride on top of the robot eventually. And so it's going to show these parts that you'll need. I'll zoom in on this. So go ahead and grab these parts out of your box. You'll already have the microbit and the cable, so all you need is the Cyberbot board. And the Cyberbot board looks like this. So it's in a largest plastic bag, has the number 32702 on it, says Cyberbot board. Go ahead and take that out of the plastic bag. And what I'll do is I'll just kind of guide you through it mostly on the video as opposed to using the checklist instructions. So with your Cyberbot board, now most of the time I'd recommend unplugging your microbit before doing this, but it'll be okay to just take the microbit and push it into this socket on the Cyberbot board. Just make sure it goes way in so that you can only see maybe the top third of these little circles, or the left third of these little circles. Again, we're going to go ahead and push the microbit into our Cyberbot board like so. Next up, and notice that in the student tutorial, yeah, it shows you the parts and it shows you how to make the connection. And then we can go to the next page. Now the next page, what it does is it has you identify which servos you have. And so the servos are going to be down further in the box. And the servos are tucked away with the chassis and the battery pack. And so what I want you to do is, this is the chassis. It's in the bottom of the box that you received. And these two little bags contain the servo motors that will make your robot wheels turn. And while you're in there, also grab the battery pack. So these are all the parts we're going to need, except for you'll also need batteries. And so
Here's a question.
go
Two
ahead.
questions. Are these the same in the BOE ShieldBot kit?
The answer is no, they're not. These servos that you have are for the Cyberbot do not require centering. The ones in the BOE, so these are the ones in the BOE ShieldBot right here. They have 900-0008 on the label, whereas the ones in your kit are going to have 900-0040. They have a little factory centered sticker over where the hole is that you normally put a screwdriver into while you're running a particular sketch for the BOE ShieldBot, and you'd adjust it until the servo stayed still. It didn't turn anymore. Whereas these guys are already all set for you. So what we're going to do is we're going to take those servos and connect them to the P18 and P19 servo ports. So see how it says P16 and P17 right there? Well, these are the 2 ports on the right are P18 and 19. And you'll want to be very careful with those white, black, red cables to have the white wire closest to the P19 and the P18 labels, and then the red below that and the black below that.
We have one participant at least who has the non-digital servos from last year because they got their kit previously, and those new servos were added, I think, in July.
Aha. So I'm probably going to, I did not account for that. I'll want to send you a link.
I can find that link.
Well, I was going to send a link to the YouTube video so that of the previous class, and we'll have you center your servos. It'll be very important to center your servos before getting started. And I do not have some servos handy to center. Sorry about that, you two. We might also just convene after the recorded portion, and we'll get you through centering the servos. Some of you may have also done that with other robots in the past. It'll be fine though. If your servos require centering, that's fine. When they get the stay still signal, they'll just turn very gradually, and that'll be okay for what we're doing right now. We'll just need to center them before you put together the robot. So go ahead and follow along, and it'll work out fine.
I have actually a link to the page from the previous version of the tutorial that has a small YouTube video showing the centering process. So I will post that in.
Okay, perfect. And actually and even in this current page, actually, if you could hold up, Stephanie, I'll paste in the current page.
Okay.
So the current page has, the current page, what it does is it says, hey, do you have the servos that we're shipping now? Well, that's great. Go ahead and skip to the next activity. Or do you have the continuous rotation servos? And there are 2 flavors of those. And if so, continue here. And so then it takes you step by step. And these are actually the step-by-step instructions for setting up your servo. And then the YouTube video that Stephanie mentioned is right here. And so just follow that to center your servos, and you'll be fine. We can also do that, like I said, together after class today.
Yeah, and I sent that other link. And we have we have a couple more questions. Okay. One is, are you able to zoom in a little more?
Oh, okay. Yes. Thank you for asking. Okay, so this is a close-up of the way you'll want to plug in the your servos.
I'm not seeing that change, but I think that folks can go to the link that Andy put in.
So you're not seeing it zoomed on my screen?
No.
Oh, that's new.
Though Nilo just did share the link so people can go and zoom in on their own screens.
Yeah, I can make it zoom here too.
There it went. That definitely got bigger. And then the other question was a general question. once students build the robot, do you typically take it back apart for the next group to rebuild it? And that
That's a really good
varies.
question, and it varies. It depends on the amount of time the teacher has for the class and what the goals are. Some teachers, especially in the more hands-on hardware or electrical hardware oriented tech ed, really want their students putting together the robot each semester. Other teachers keep them built up after the first semester or after the first time they use them. And then what they'll do is just, hey, we're getting started with the robot. Here it is. Let's check and make sure the servos are calibrated. And after that, go ahead and start navigating. So there's various levels of depth that can be achieved either by taking it apart and rebuilding the servos each term or not. And so that's totally your call. And it depends on, how much time you have in your class and what the goals are in terms of the experience for the students. All right, so with all these parts out, you've got your battery pack, your servos, and so what we did was plugged in the servos to the servo ports on the Cyberbot board with the white wire closer to the P18 label and the P19 label. So I plugged in the P19 servo, and now I'm going to plug in the P18 servo, or the other servo, into P18. That's the 3-pin ports in the upper right of the Cyberbot board. And here we are. So there's P18 and P19, and we've got the white wires closer to the labels of P18 and P19, and then they're plugged into those 3-pin servo ports. Make sure they're all the way down onto those pins that are sticking up from the servo port. You don't want them to be just slightly plugged in like so. You don't want to see those right here. We can see some of those pins sticking up, and we don't want to see those pins. We want them plugged all the way down so that the plastic meets the plastic of the plug meets the plastic of the servo port. And I forgot to mention, we're customizing this for the intro. I'd also like you to grab your wheels, the 2 wheels out of there's a plastic bag with some more robot parts, and just grab the 2 black plastic wheels out of that bag, and they mate with the little gears that come off of the servo. So these 2 gears right here, AKA splines, the output shaft or the servo spline, you'll see them referred to in that way, depending on where you're reading about servos. Output shaft, spline, final gear. That's this guy right here. And there's a hole in the wheel that will mate with it. Just go ahead and gently press each wheel onto the top of the servo. And then we'll go ahead and also plug the battery pack. It has a barrel jack, and the Cyberbot board has a barrel plug. Last but not least, we'll need to add 5 AA batteries to the battery pack. Make sure the little power switch is set to 0. So there's a power switch, PWR is what it's labeled along the bottom. So this little switch right here has 3 positions. It's currently on 0. Middle is 1. Far right is 2. So we want it all the way to 0. And we'll go ahead and put the batteries in. Make sure to put the flat end of the battery, that's the negative terminal, up against the spring. I'll show you the little plus minuses on each battery there. So that's the way you want it to look. All right, how are we doing? Can I get some thumbs up on all the mechanical or the electrical connections there? Got a check mark, thumb up, okay, and some smiles even. All right, everybody. Excellent
yay.
work.
That includes our attendee with the older servos, the needed manual adjusting. So
Perfect, perfect.
good.
Yeah, and that'll be fine. It's just like I said, when we use the statement to make it stay still, it's just going to turn gradually, and then you can adjust it with a screwdriver to make it stay still. All right, so before we can get the microbit to communicate with this Cyberbot board to make it turn, let me tell you a little bit about how that works. And so this was this also harkens back to the question about, there was a question earlier on about the IO pins that are different from the microbit. The microbit right here, let me see if I can get you a better view of this. There we go. All right. So the microbit, when you plug it into that socket on the Cyberbot board, what it does is it sets up an electrical connection between some of the pins or some of the pads on the microbit and some of the pins on this propeller microcontroller that was designed and made by Parallax. And there's communication between the microbit and the propeller using something called an I2C bus. That's just basically a particular type of sequencing of high and low signals that microcontrollers can set and deliver to each other to transmit information. And then the propeller microcontroller is going to take the messages it received from the microbit, and it will do things like send a control signal to the servo, and it'll make these lights go on and off. And it can monitor or control circuits by connecting them to these sockets along the left side of the breadboard. And then there's power connections up above, 3 and 5 volts, ground below, and then some digital to analog and analog to digital sockets. I'll touch on those later. And the idea is that this is similar to the Board of Education and the original Bobot robot. And so it's not matching the microbit because it is matching our robotics curriculum. And also there is a second microcontroller. It's underneath this breadboard right here. So the propeller microcontroller system is all right here below the electronic and electrical prototyping breadboard on the Cyberbot board. This white board is commonly called a breadboard. Now, to get the microbit to communicate with this, we need an extra Python file that's added to the microbit's file system. And the way we do that is introduced, I'm kind of jumping around now. The way we do that is introduced in the Add Cyberbot module to your project chapter. And so I'll go to that. And I'll also show you where to find it in the student tutorials. So this is the add modules to your microbit. And it takes you step by step through downloading the zip file, shows you with an animated GIF how to unzip it. The proper pronunciation is GIF, I'm told, but I still call it a GIF because it's spelled .gif. And then it takes you step by step through adding it to your file system, which takes us into the load save button again. And so let's go ahead and do that now. I'll go ahead and text you the link to, so you want to right click before I text you the link. When you follow the link I text you, it'll take you to this page. And I want you to right click the Cyberbot, or hold on, let me make sure I've got that right. Okay, so right click and open a new tab when you get to the Cyberbot Library Archive link. And actually, no, I'll just paste you this one. Okay, and then what I want you to do is right click and select Save Link As, where you see the zip download in the lower right. So I'll paste you this page, and then we'll want to unzip that. So here comes the page in the chat. And then we'll want you to right click the download button and select Save Link As, and go ahead and just save it to your downloads, preferably. Okay, and then go ahead and give me a thumb up when you've got that archive, that zip file downloaded. Good job, excellent. Oh, you guys are fast. All right. I'm going to wait for a few more thumbs up before continuing. Oh, thank you. Excellent. Got one over the chat. Good job. Okay, give me a shout out if you need me to wait a little longer. Otherwise, I'm gonna go to the next.
We have a question. Should we run it?
Oh, well, it's not a case of running it. It's a case of unzipping it. So the next thing we want to do is after you download it, you're going to download it and then you're going to unzip it. So it's showing here how you right click or how you click it and it downloads. And then you can show it in your file folder, and you want to either open it and copy the folder that's inside the zip and then paste it into your downloads or your desktop or wherever you want to keep it. Or you can, in many cases, double click it to unzip, or you can right click and select. Stephanie, do you remember what the unzip is in Windows when you right click it?
Extract.
Extract all. Yeah.
And then you want to extract to here, wherever you
Yeah. So when I downloaded it, and then you can click the little caret next to the download and select show in, for me, it's show in Finder. For you, it might be show in Files or show in Windows Explorer. And in a Mac, you can just double click it and it will unzip the whole thing and enumerate it if you already have a folder with that name. Alternatively, you can, I don't think I can, I don't know if I can browse into it. So normally you would right click with Windows and select extract all. And when you're done, you want a folder named cyberbot-micropython. So you don't want, so there's going to be a zip named Cyberbot MicroPython and a folder named Cyberbot MicroPython. And I apologize, I used to be able to zoom in using using some keys to magnify everything, but it magnifies for me, but I see that it doesn't magnify for you anymore. I'll have to look into that and see if there's a way to correct that. All right, so give me a thumb up when you have both your zip and a Cyberbot MicroPython folder. Excellent, lots of thumbs very quickly. You guys are fast. Okay, looking good. All right. Again, give me a shout out if you need any help. Okay, so now that we have our Cyberbot MicroPython folder, what I want you to do is go to your Python editor. And again, this is also documented in the step-by-step in the chapter for this, which is done earlier on. So so I'm just showing you on the Zoom how to do it. So what you'll want to do is just go ahead and refresh your browser so that you're in your in like the default script. Then click Load Save. It's the third button. Click Load Save. And in the dialog that comes up, click Show Files. And it'll show you the main script right here. Okay, are we all at this screen? Thumbs up, please. Or
Do you
down.
have a question? Do I continue with the V3?
Yeah, so in the V3, let's see here. I think you go to Project. So that's along the left in the lower part. And then you select Open. And then go into Cyberbot MicroPython, select cyberbot.py and click Open. And then confirm when it asks you to add a module. Then you'll see it along the left in your project list. For most of us, what we want to do is we want to be here and click Add File to do that. So once you're at the load save, you'll hit Add File. You'll go into your downloads. And then you'll see a folder. And I'm sorry, this is hard to see. I need to come up with an alternate way to magnify stuff for Wednesday. Go into the Cyberbot MicroPython folder, select cyberbot.py and click Open. And once you've done that, you'll see two files in your project files list. Your main program and cyberbot.py. Okay, I see folks still working away. Give me a thumb up when you either when you can see cyberbot.py in your project files, or when you can see cyberbot.py in your project files in the version 3 editor, if that's what you're using.
I just want to reiterate, there's a question. I have been able to get several tutorials to work with version 3. Is there a reason not to use it? I just wanted to say the reason why we're using version 2 is because these tutorials were created prior to version 3, and so that's how they're documented. And we would not want to try to change that documentation during the school year, so that's scheduled for the summer. And have we run into any problems with the version 3 to your knowledge, Andy?
It does everything the version 2 does. It's just it's different. Like, for example, load save. If you're going to save a file, you hit download project hex. In the V3 editor, the save button's right there, which is pretty nice, I think. When you open Serial, let's see, where is that button? It used to be right down here.
It only shows up after you actually have asked it to do any serial.
Ah, thank you. That makes sense. Yeah, everything works just great in the version 3 editor. It's just that the interface looks a little bit different and you have to click different buttons. Things are in different places. So this is not in sync with our tutorials yet, or actually the vice versa. Our tutorials are not in sync with this yet. So that's why we're using version 2 primarily. Okay, have a hand up, Kathy? You're muted. Sorry, you're muted. I can't hear you.
I'm sorry, I
That's
forgot
okay.
to mute. When I got to the point to open the Cyberbot MicroPython folder that was in there, it shows a folder of circuits and a folder examples, and then a whole bunch of other .py. So do I?
You're
click-
looking for cyberbot.py. Let me see. So if
Oh,
I hit
there it
add
is.
file.
Okay, thank you. Now I see it.
Oh, good, good. So you found it. Yeah, because there's a circuit subfolder and an example subfolder, and you just want to grab cyberbot.py and open that.
Okay.
All right, so let's check everybody to make sure that that it's working. I'll go ahead and just do a quick little example here. So let's call this cyber template. I'll paste this in a second. Okay, bot dot write digital of 20 or bot of 20 dot write digital of 1. And the way we'll know this works is if a little light right down here turns on. Okay, so this should turn on a light if I've done everything right. Look right down here. And I made a syntax error. I forgot to say from Cyberbot import. Let's try that again. And my light didn't come on. And the reason for that is because I didn't turn the switch on. There's this 3-position switch right down here. And I want to turn that all the way either to 1 or 2. So either the middle or the far, or go all the way to the right. Either way is fine. And then this little light, this little amber light below the number 20 should come on. So I'm going to, and this is going to be important. Before I paste it to you, watch this. We have this, we want to save this as Cyberbot template because we're going to be reopening this hex file. So Cyberbot template is what you want to name it, and you want to hit load save and download project hex. So now I'll paste it into you. I want you to make sure that your amber light comes on. And again, you'll have to set the 3-position switch either to the middle or the far right position. And you'll have to, you've got to have the Cyberbot module added to your file system. That's in here. And then when you run the script, your amber light should come on. So let's make sure that that works for y'all. Here is the script to paste in. And no, you do not need a semicolon at the end of lines. That's a C programming type of thing. In Python, the carriage return indicates that you're on the next line. I forget sometimes too. You'll often see me accidentally adding semicolons when I'm not supposed to. Okay, so give me a thumb up when you've got that running. And I have a hand up, Katie.
I think I might have gotten it. I was just wondering, like, I think I have it. So I have everything you wrote in there, and then I hit open serial and then download, right?
Click
Or did you not
connect.
say that?
Yeah, you don't need open serial for this one.
Just
'Cause
connect.
Yeah, connect and then flash.
Can you
And
show
then-
us again where that light lights up, Andy, please?
Oh, yes. Okay, so the light is going to light up right there. So you're looking for an amber light. Oh, and I said under, it's over the P20 label. See that P20 label right there? And how there's a little amber light on.
Mhm.
And I still have both Kathy and Katie's hands up. You
My
guys are,
amber light is not on.
okay. Now, did you set the 3-position switch to 1?
Yeah,
Okay, is there a green light above the 1?
yep.
Good. And then hopefully there's not a red light in the upper right of the board.
Nope.
Okay. And let's see here. And then click load save and then show files and verify that you have cyberbot.py.
I have Cyberbot template main, and it's, yeah, mine looks just like yours, cyberbot.py.
All right. So
Oh, wait, was it supposed to say download Python script?
yeah, or rather Flash in the upper left. So you want to be connected. Okay, so you have to hit connect. So if you're disconnected, it'll allow you to download. If you're connected in the second button, then the first button is flash. And then when you flash it, hopefully
Oh,
the amber light comes on.
hey, it's on.
You got it?
Yeah.
Excellent. Kathy.
Okay, so when I clicked on the cyberbot.py, it opened 57 line or 77 lines of code.
Oh, wow.
Yeah, so
Sounds
this
like
is
you
very different
opened
in the version in the V3.
Oh, in the V3, yes, you can.
Yeah.
In the V3, you can actually look inside the Cyberbot module.
It's huge.
Yeah, we did a lot of heavy lifting under the hood for you. But your program is here under main. So this one, you and your students are going to be doing this. And then, yeah, some of the computer science students may be interested in this, but we had to make this ultra compact, and so it's very difficult to read code wise.
So
The
then,
fewer characters you use, the less microbit memory it takes.
okay, so it has been saying hello. It gives me a little heart.
Okay, well, that means that you still need this script. I'll go ahead and paste it in. Again, copy and then chat. Okay, paste. Okay, so you should, so you want this script. I'll go ahead and so yeah, you need this script. Needs to look like this.
Ah.
And then try it and you should get the amber light. All right. And we've only got a couple minutes left, and so I'll take the rest of the questions afterwards. I want to make sure that we've got some wheel speeds going. So what I want to do next is I'm going to modify this script a little bit. Bot of 18 dot servo speed, and this is from the tutorials. I'm just trying to make it go quicker here. Servo speed of, let's do a slow speed, like maybe 40, well, we'll do 50. And then bot of 19 dot servo underscore speed of -50. And actually, I'll go ahead and paste this in a second. Okay, hopefully this will work. Flash. See if I made any syntax errors. Okay, we'll need to have the 3-position switch in position 2 for this. And there's a reset button underneath the microbit for restarting this. So because it's going to make each servo turn for 2 seconds, let me bring your attention to underneath the microbit. Right next to where you connect the USB cable, there will be a reset button to restart your script. Okay, so I'm going to go ahead and turn this over. Press and release to restart. And then the servo connected to P18 should turn for 2 seconds. And then the servo connected to P19 should turn the opposite direction for 2 seconds. First one will be counterclockwise. The second one will be clockwise. Okay, copy and paste. Okay, there is your script. Now we need to use our template for this. So don't close and reopen anything. Just paste over, and we'll rename it servo speeds. Because we want the that Cyberbot module. Cyberbot module is required for all of these things here. Remember to have your switch in position 2 down here, and then you can run the script, and you want to see one servo turn slowly counterclockwise for 2 seconds, then the other servo turns slowly clockwise for 2 seconds, and then everybody stops. And for those of you who have the older servos that need to be calibrated, they're going to kind of I set it up for none, so it's actually going to bring everything to a dead stop. If you set a speed of 0, it would turn slowly. Okay, I'm seeing some thumbs up. I can't hear you, Kathy, but got some more thumbs up. Can you everybody give me a thumbs up who got it running? Okay, some of you are still working on it. Great. Good job, everyone. Now, what I'd like you to do also is experiment with this 50 and -50. Try 100. Try 125. Let's go all out. 125, that should be close to top speed. 150 is overdrive. It's top speed and some, and you'll only get top speed out of the servo, which isn't a bad thing. You can go up to plus and minus 200, but you only see speed changes between, say, 25 and -20, or at 25 and 125.
We have the question, do we have to reboot the microbit every time we change the code?
Well, this particular script runs out of statements with everything stopped. So in order to rerun it, you can either reflash it, or you can press and release that reset button underneath by the USB cable here, and that'll restart it too.
And another question, what happens if we go too high with those numbers? I'm assuming the servo speed numbers.
Yeah, so if you go way high, the servos might not respond. Basically, top speed is, if you really want to be sure you've got top speed, 150 and -150 would be top speeds for counterclockwise and clockwise, respectively. Normally, though, it hits top speed about 130, 125.
Another question, all of this code could be executed directly in the serial console.
Possibly, if you're talking about REPL, I'm not so sure. I haven't tried doing that in REPL. Normally, it's just executed by writing a script and then clicking flash. REPL is the serial console where you can do specific messages with the microbit. So, like I can say print hello, and it'll display hello for me. I haven't tried pasting the script in here one piece at a time. That's not normally something I do. We just show the students how to write it as a script, as a Python script here in the editor instead. Oh, it worked in REPL. Thanks, Randy. Good to know. All right, I don't know why mine kept on turning. So the main thing here is that we have control over speed and direction. So here I'm at top speed. If I was at 130, I'd still be at roughly top speed. And if we want to go half of top speed, 175 might be about half speed, or pardon me, 75 plus and minus 75 would be half speed, counterclockwise and clockwise respectively. And so this is, although this is not specifically done this way in the chapter currently, I'm kind of thinking about adding this as an activity so that the students can see how they're controlling the servo's speed and direction. Then you can make it go really slow, like with a 30 and -30. Flash that. And then they're going to turn really slow for 2 seconds. Hopefully that's visible how slowly they're turning in the video. Now make sure to save the servo speeds. We're going to try this again when we and you can also do them both. I'll paste you in one more and then do a few final comments. Sorry, I'm keeping you over by about 5 minutes, probably 7 by the time all is said and done. Okay. So we can keep them both running here. For 3 seconds. Oops. Okay, so we'll keep them both running at the same time, and then we'll make them both stop. And I'm flashing that just to make sure it doesn't have a syntax error. And better give it the correct name here too. So does everybody see how I'm using the numbers to control the servo speeds and directions? Okay, I see a nod and a thumbs up. Okay, good, excellent, thank you. Okay, paste. So there's our final script where it makes one turn, then another turn, then both turn. And let's make sure to save this one because we'll do it again once we put the robot together. So I get the left wheel turning a little bit, then the right wheel turning a little bit, and then both wheels. Oh, they're not both turning simultaneously. Oh, darn, I did a syntax error, or I made a mistake. I didn't do 18 and 19. So let me paste the corrected code. We'll have you try it. Sorry about that. Okay, so now in your chat should be the correct code. We want to see the P18 servo turn counterclockwise, P19 servo turn clockwise, and then both of them turning counterclockwise and clockwise simultaneously. Pretty cool, I hope. All right, so a couple final things. Here's a little visual on selecting which servo to control and which speed. And it shows that our main speed control is between about -25, -125 for clockwise, and between 25 and 125 for counterclockwise. Overdrive is okay up to plus and minus 200. I haven't tested beyond that, but eventually you'll come up with such a crazy number that it won't run. And then here's a little graph of those speeds. So there's a little space in the middle. That's why I'm giving it plus or minus 25. It's actually closer to say plus or minus 10, 15, where there's no speed. And then as you get a larger number, its RPM goes higher and higher up until about 130. Then it levels out. And then likewise with the negative, it goes clockwise till you get to about 130. And there's also a little explanation in the text about how pulses are delivered to the servos, which are brief on-off signals. Like the on part is when the amber light came on, for example, and then the off part would be the amber light is off. And these signals last a very small amount of time and are repeated 50 times a second. That's every 20 thousandths of a second. And that's the control signal that will make the servo turn counterclockwise or clockwise or stay still. And so what you'll be doing for homework is we'll be gathering all these tools and parts. Make sure to find the little wrench. You'll want to have that. There's a little wrench in your kit. It should be in there, I believe, with the where you got the wheels out of. The little wrench is hiding in there. So make sure to grab that wrench. You'll need the screwdriver that comes in the box. Looks like that. And then one thing, when you, this is for your homework, you'll be putting together the robot. When you put the servo in, you want those output splines to be closer to the middle of the robot, not closer to the front of the robot. And very important, don't forget, like I always do when I'm running these workshops, to unplug your power when you're done, because there will be some power draw on your batteries, and we want your batteries to live through this whole workshop. So so go ahead and turn your power off here at the switch, but also when not in use, unplug the battery pack's barrel jack. That way you're not taking any power. Now, things that you won't be able to run Cyberbot programs until you plug the battery pack back in. That's a requirement. Battery pack, power switch to 2 for servos or 1 for anything else on the Cyberbot board. And but again, unplug your power now. And then for homework, there's a chapter, and I'll send you the list. It shows you step by step how to go through, and you're basically going to go through and say, okay, I'm going to grab all these parts, and then once I've grabbed all the parts, I'll go to the next page. So that's down below here. You can navigate to the next page, and then it shows you, it lists the parts that you'll need. You'll gather them, and it shows you how it looks before and how it should look after. And so this is connecting a couple of standoffs to the front of the chassis and adding a little rubber grommet. And then you'll go ahead and keep going. And this part, you don't have servo horns on, you don't have any plastic parts to remove, so that's okay. So you're already in this kind of situation right here. And then installing the servos, again, make sure to set them up. So this is how to use the wrench to hold on to a nut. And you've got a choice of nylon lock nuts or non-lock nuts. And the nylon lock nuts, I think, are pretty good since you've got the wrench. It's a little harder to, it takes a little bit more effort to put it together, but it won't shake itself apart after it's together. And it shows how you can, and I don't recommend this outside mounting. I recommend this flange going in from the inside, but really either way is fine as long as that output spline, output shaft is close to the middle of the robot. You don't want it up front here, you want it in the back. So here's an example of both of them in. So it just goes ahead and shows you step by step how to do how to put the robot together. And so that's what we'll have you follow. And so when we reconvene on Wednesday, we'll have robots that are fully assembled. Sorry for keeping you after for 12 minutes. I apologize for that. But that's all I've got to show you for today. And like I said, we'll reconvene with Cyberbots that have been assembled, and we'll start on navigation and even do some sensor-based navigation on Wednesday. So after we will have tech support and general discussion after the recording stops. But this is the end of the official recorded portion. Thank you for coming, everybody. You're more than welcome to stay and talk and get some help, or otherwise expect a homework and a link to the YouTube video, and we'll see you on Wednesday, same time, same Zoom link.